I'm really pleased to be here. It's such a thrill to talk to you all about something that I feel really passionate about, and that is the fact that we used to have bacteria under control and we're losing the battle, and we really need to do something about it. So this story starts a very long time ago, 4.6 billion years ago, when the planet was formed. It looked a little bit like this, perhaps, and it was really hot and nothing could live. But almost as soon as the Earth had cooled enough for life to form, bacteria arose. 3.5 billion years ago. That's a long time by comparison on this timeline. Mammals and humans, 200,000 years ago. It's just a tiny little pixel at the end of this story. So bacteria have been on the planet for billions of years before we even got here. So they're really, really old and really, really, really smart. And not only are they ancient, but there are an awful lot of them. So there are 5 million trillion bacteria on the planet. That's more than the number of stars in the universe. That's quite a few. And this is the sobering bit. Right now, on you, in your hair, in your nose, between your toes, inside your gut, you are just loaded with bacteria. 100 trillion bacteria on you right now. That is 10 times more bacteria than you. So you're not even human, mostly. So that's a sobering thought as well. So lots of them, and they're very ancient and wily. Okay, so because of this, so bacteria can be good. There are good bacteria. There's friendly bacteria. We're not here to talk about the friendly ones. They've been causing problems for our species for almost as long as we've had historical records. One of the lowlights of bacterial problems was in the medieval period, when probably up to 1/3 of the European population was decimated by this tiny, tiny little bug called Yersinia pestis. It doesn't look very impressive there, but it brought Europe and the rest of the population to its knees. And the only thing you could do back then, there were no drugs. You could hire your local priest to sprinkle some fairy dust on you and perhaps pray a little bit. Otherwise, you were toast. So Yersinia pestis is still around. It can cause the Black Plague, but it's under control because we have antibiotics. It's under control for now. So remember that. Okay, so we are higher organisms, right? We're the top of the food chain. We are the big guys. How come we still get sick? Because we got these amazing immune systems, right? We're advanced organisms. These little guys are tiny. Why do we still get sick? And the answer is because bacteria have amazing defense mechanisms. They have ways of getting around our defense mechanisms. They're always ready to outsmart us. And I'm going to give you an example of my favorite bug, E. coli. So E. coli, you've probably all heard of E. coli. It's one of the friendly ones, right? It lives in your gut. And if you go to the toilet, you smell that wonderful smell. That's E. coli you're smelling. Love it. So E. coli looks a little bit like a Tic Tac. It just hangs out in your gut and does nice things for you, like it helps you digest your food and so forth. But when E. coli gets into the wrong place, or it's the wrong kind of E. coli, really bad things can happen. And I study urinary tract infection, which is a conversation killer at any party, I can guarantee you. What do you study? Urinary tract infection. But it is a huge problem. It causes lots of problems for the elderly, and it is one of the most common infectious diseases in the world. And E. coli, normally, people used to think it just hung out on the outside of cells and just caused some inflammation, but that's not what it's doing. So this is an image of a normal mouse bladder. And if you put E. coli into a mouse bladder, this is what happens. What is this? This is a pod. Ladies and gentlemen, this is a pod. What it is, this is a bladder cell. And that's a big, huge blister. And that blister is full of bacteria because the E. coli have actually physically burrowed into the bladder cells, through the plasma membrane, and start replicating inside your cells, believe it or not. And then it forms this blister, and the blister gets bigger and bigger and bigger. Can anyone guess what eventually happens to this blister? Pops like Alien, and they all come out and reinitiate infection. This is why many women get UTI over and over again, because it can hide in there. And when it's in that pod, it's nice and safe. The antibiotics can't get in, and the immune system can't get in, so they can regroup. So that's one of the mechanisms that E. coli uses to outsmart us. And it's got others. It's got more tricks up its sleeve. So normally E. coli looks like a Tic Tac, which you can see up there. But when it bursts out of those alien pods, it looks like that. It looks like spaghetti. A long filamentous form of E. coli. It's only seen in bladder infection. What is this doing? Well, scientists have worked out that it's doing two things. The first thing is, if you're shaped like a Tic Tac and you're in a bladder and your host decides to urinate, it's like a fire hose. You're just spurting right out there. You cannot cling on. But if you're shaped like a spaghetti, scientists have proven that you can actually cling in to the bladder. Right, so here you are, you're the spaghetti, you're being blasted by urine, and you can still stick in the bladder. Just like taking a wet piece of spaghetti and throwing it against a wall and it sticks. You've probably all done that. So that is one of the things that E. coli can do in the spaghetti shape. The other thing you can do is even more amazing. I'm going to show you this video. Okay, what you're looking at here, the big gray background, these are bladder cells in the lab. The blue guys are white blood cells. They're the ones that are supposed to be hoovering up and eating all the bacteria in the bladder. And that green thing is a long filamentous spaghetti-shaped form of E. coli. And the tiny dark gray tic-tac shapes are the normal E. coli. So I'm going to play this video and watch what happens with the white blood cells. Okay, they're going nom 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 nom. They're eating all the tic-tacs. Nom 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 nom. However, they're not eating the green spaghetti. And we actually don't understand why. Either they can't see the spaghetti, it's like an invisibility cloak, or it just doesn't taste very good and they don't want to eat it. Either way, it's a great way to survive in the bladder, despite the fact that the immune system is there. So bacteria are very clever. And I could give you hundreds of examples of bacteria getting around us like that. So this is really super important because back in the day, before there were any drugs to fight bacteria, it was really dangerous being a human. So if you had an operation, you've seen already some great talks showing how operations are actually mission critical for keeping us healthy, kids and adults. But in the old days, if you had an operation, it could be deadly because there were no antibiotics to help fight the bacteria that could get inside your body when you're cut open. And in fact, 1 out of 3 deaths was associated with a bacterial infection back in the day. So this all changed during this very famous moment when you've probably all heard about Alexander Fleming discovering something interesting in his petri dish. We don't know if this story is strictly true because it's a really good story, but probably what happened is he had his petri dish and he was studying bacteria. It was growing all over his petri dish, and he went away on holiday and he left the lid slightly off. It wasn't on properly, and when he got back a few weeks later, there was a big, massive wad of mold stuck on the top of his petri dish, underneath, inside there. And a bad scientist would have just said, oh, stupid me, and thrown it away and gone down the pub. But Alexander Fleming was not a bad scientist. He was a good scientist. He had curiosity, and he thought to himself, yeah, I messed up here, but this is odd. It's almost as if this mold is killing this bacteria, because there was a big swathe of nothingness around it. He thought, I think the mold's actually making something that will kill this bacteria. And that's when he thought, whoa, we're onto something here. Indeed, he was onto something, but it proved too difficult for him, and he abandoned it, actually. And it was left to biochemists to come to the rescue, Flora and Shane, and the 3 of them shared the Nobel Prize for this amazing discovery of penicillin back in the 20s. Okay, so what is penicillin? What is an antibiotic? Well, in this case, penicillin is a natural and ancient product of microbes. Penicillin is billions of years old. It didn't just suddenly come to existence because Alexander Fleming discovered it. It's been there for ages, doing what bacteria do best, which is fighting each other. So bacteria have to fight for territory just like people. And this is an ancient product that we happen to discover. And what does it do? Well, bacteria are always making holes in themselves. Every time they divide in half, you have to repair the hole or they burst open. So what penicillin does, it just prevents the bacteria from self-repair. And when that happens, the bacteria blows up. So in the presence of penicillin, bacteria explode because they can't repair their cell wall anymore. It's a really great strategy because it doesn't affect our cells. It only affects bacterial cells. It's a silver bullet. However, things were not rosy. Even back, Alexander Fleming, he gave his Nobel Prize acceptance speech at this gala dinner, 1945. Instead of being all how bigging himself up and saying how great he was, he used that opportunity to share his concerns about his own discovery with the people there. And he said, I want to sound one note of warning. And this guy, if you read a transcript of this speech, it sounds like he's a time traveler from the future. He's saying things like, I'm really worried that people won't take the full course of their antibiotics. I'm really worried that people will take it for viral infection and just misuse it. I'm really worried that people will order it off the internet. No, he didn't say that. But he would have said that if there had been an internet. He was worried because in his own lab, he saw that penicillin suddenly would just stop working. A bacteria that yesterday would be killed by penicillin, today could not. And he thought, this is going to start happening if you're not careful. And boy, was he right. The same year, word started to filter back from World War II, where they were deploying penicillin, that people had infections that were already resistant. So what is resistance? When you hear antibiotic resistance, what does that actually mean? Well, what it means is that the bacteria, because they're clever and they're ancient, have mounted a defense, their own defense against infection. So here's an example. This is penicillin again, the structure. And that enzyme is beta-lactamase. It's an enzyme produced by bacteria that simply snips that four-membered ring. Penicillin flops open and can no longer do its job, which is to prevent the cell, to stop those enzymes that are preventing the cell wall from repairing. So this is an antibiotic resistance gene. It's encoded on a plasmid, which is, of course, a tiny little piece of DNA. The bacteria can pass around like business cards. Hey, I've got this really interesting gene. Would you like to have it? It's really easy to spread. And once you have a problem like penicillin, the bacteria are more likely to survive if they have it. So here's an example. This is simple Darwinian evolution. It's a petri dish covered with white bacteria which are sensitive to penicillin, and one mutant in red that's resistant to penicillin. What happens if I flood this plate with penicillin? Yes, exactly. All the white ones die, and all the red ones take over. Now imagine instead of a petri dish that this room, most of you are the sensitive bacteria, there's one of you, maybe you're the mutant that's resistant. If I flood this room with penicillin, if you're all popping penicillin pills when you shouldn't be, you're going to survive, everyone else is going to die, you're going to go out to the London Underground, you're going to go get on a plane to Hong Kong. Next thing you know, this resistance gene is everywhere because of natural selection. Okay, but something even stranger is happening. So back in the day, we discovered lots and lots of antibiotics in the last century. They all worked for a long time, 10 years, 15 years. One antibiotic even worked for 20 years before there was any resistance recorded. But something weird happened in 1990 around then. They just stopped working. So we invent a new antibiotic, boom, instant resistance. The bacteria were all over it. Something happened. And what was happening? What we think is happening is that the misuse of antibiotics that Fleming was so worried about back in 1945 was really taking off. So people could buy penicillin for 60 or 30p on the internet. They didn't need a prescription. There's some countries where you don't need a prescription. You just go to the pharmacy and say, I've got a cold, can I have some antibiotics? And they say, sure, take 3 boxes. We also started to dose our animals with lots and lots of antibiotics. And this is just essentially like the Petri dish. We're flooding the planet with antibiotics and selecting for things that are resistant. So we're now in a serious perfect storm situation where we're running out of useful antibiotics and we're not making any more. So in the golden era, back last century, 20 new antibiotic classes were discovered up till 1987. And people said, you know what, we got 20 classes of antibiotics now. Let's just stop making them. We don't need any more. We got 20. Let's work on cancer, let's work on stroke, let's work on all these other problems. That's fair enough, right? But then resistance began to arise in all of them, but we didn't reverse and start making more. No new antibiotic classes have been discovered since 1987, which is before, I guess, most of you were born. No new classes have been discovered, and here's just a graph showing plummeting amounts of approved new antibiotics by year. There haven't been any. And if I tell you that it takes 20 years to get from eureka discovery in the lab to a new antibiotic, 20 years, and sometimes it doesn't even work, right? So we're already starting from a situation where we're in trouble, and even if we discover the next new antibiotic tomorrow, it might take 20 years before it's approved, and it might not work at all. So this is a problem. So what happens to bacteria if they're not treated with drugs, if they're not opposed by the immune system, if they're just left to grow unchecked? I took this video just as sort of a way to illustrate how scary it is. So what you're looking at here is a dish full of human bladder cells and the little tic-tac shaped things with our friend E. coli again. I just sprinkled them in there and set up a video camera. And I left it running overnight. Of course, they're doubling every 20 minutes, exponential growth. Sometime around midnight, you could no longer see the cells. And then by the time the morning came around, there were no cells left. The whole flask in this case was just full of E. coli. So this is what happens in a body when there's nothing to fight the bacteria. Okay. So a lot of people think about the antibiotic resistance crisis. You've probably heard about this on the news. You probably think, oh, that's something to worry about in the future. It's something that's going to happen later. But actually, the future is already here. So here's a report from the Centers of Disease Control in the United States, 2013. 23,000 people die each year from a bacterial infection that cannot be treated by any known antibiotic. 23,000. That's just in the States. And there's similar figures for other countries. European Union, 25,000 people a year. And right here in this wonderful place, this is a girl called Isabel. She was suffering from a bacterial infection, and they basically had given up hope. Nobody could cure her with any antibiotic. It came actually to these wonderful creatures called phages. These are viruses that infect bacteria. Some scientists worked together with the doctors here and came up with a cure based on viruses fighting bacteria. It's kind of like Alien versus Predator. Really interesting idea that's now starting to take off. Okay, but I think it's really important to stress that this is not a new problem that we only just heard about yesterday. This is just a quick media review. You don't have to read it all, but just look at these ancient years, 1961, 1966, 1967, 1972, headlines warning us about the antibiotic resistance problem. It's not a new problem. We've known about it for generations, several generations now, but nothing ever happens. Nothing gets done. We just keep worrying about it and talking about it, but nothing ever happens. And this is why things are getting a bit apocalyptic now. People are using the word apocalypse in the headlines now. They're talking about it's worse than climate change. It's worse than terrorism. It's going to lead us to the medical dark ages. And a lot of people say, oh, that's just scaremongering. I'm not so sure it is, because we tried the nice, gentle headlines, and nobody listened. So maybe it is time for us to start talking in these terms. And there was a very, very scary report, if you really want to scare yourself. You can have a look at this, the O'Neill Review on Antimicrobial Resistance from a couple of years back. The global cost of no action to this problem, 10 million deaths a year by 2050, at a cost of 69 trillion pounds a year, if we do nothing. And that's a lot of people dying. So, to end on a note of hope, I think we need less talk. We all know about the problems. We need more action. We need interesting solutions to this problem. There's a number I've listed here. Phage therapy I've mentioned. We need new antibiotics. We need to go to extreme environments, find new bacteria that are making new different kinds of antibiotics. And once we have those new antibiotics, we have to protect them. We have to use stewardship to make sure they're not overused. Probiotics, using bacteria to fight other bacteria. Engineers are coming up with smart surfaces to be used in hospitals that can't be infected by superbugs. Gene editing, CRISPR, can be used to eliminate antibiotic resistance genes. And finally, not to forget, our old friend, the vaccine, which is much maligned these days. A lot of people are turning away from vaccines, which is tragic. But bacteria can be vaccinated against, and perhaps we just need to do more of that. So, your idea here. What we need are smart new ideas, because this is a crisis. And what I'm hoping that I've done today is to inspire some of you, if you're interested in biology and you're interested in medicine and you want to help save the planet, I really hope you'll go into this field, because we need the next generation of young people with their ideas to help us. So do join us if you have an interest in this.